Alrighty, good morning. So Friday, you're taking your test, and then you are watching this video and you are taking notes. So you will have an interactive practice after this. So make sure you take good notes. So remember yesterday I told you we are going to extend our understanding of linear inequalities, and we are going to talk about systems of linear inequalities. So the first thing I want to do is remind you about just graphing equations. So when we graph an equation, the line represents every solution to that linear equation. But when we graph an inequality, the solution is represented by an entire region. Remember, we do that. That's why we shade. I'm going to put the shaded area. So we represent this region by shading. And remember, we shade either above when it's greater than or equal to, or below when it's less than or equal to. So remember that we use a solid line. We did this yesterday. A solid line, if we're including the points on the line, that means it's got the equal sign underneath it, or that equal bar. Less than, equal to, or greater than equal to. And we use a dashed line when we just are not including the line in the solution. So we use the symbols less than or greater than. Remember, if it's greater than, we shade above, just like I said before. And if it's less than, we shade below. So remember, the solution region is where the shaded region overlaps. So when we talk about a system, we're going to have two equations. So I know that you can't see the color, but I just want to show you. So let's imagine that this is our first inequality. And I'm just going to write this equation here so you can see it. So this is the equation y is less than 2x plus 5. So dashed line crosses the y-axis at 5, has a slope of 2, and because it's less than, we're going to shade below. Dashed line, shade below. So I'm going to repeat that on the second one. Just reiterating that same inequality again. And remember, we shaded below. And then the next equation, this is the equation y is greater than or equal to negative 1/2 x minus 1. So this is going to cross the y-axis at negative 1. And because it's greater than or equal to, we are going to shade above this line. Something really unique happens when we shade above this line. So you'll notice that the solution is actually the region where the two shades overlap. So I'm using highlighters, and that's probably the most effective way. Another way that you can do this, because if you don't have access to, let's say, crayons or markers or colored pencils, if this was my first solution area, this was the yellow region that I shaded, right? And then this is my second solution area, and this was the blue region that I shaded. Notice the space, the solution area for the system, the solution region for the system is the place where the two lines are like cross-hatched, right? So that might be a better way for you to use it if you're not using colored pencils or highlighters. So that's what we're going to do. So I'm going to graph these three systems, And then we're going to do a special one down at the bottom that has a polygon. It creates a polygon. So I want to talk about the steps. So remember, when we're graphing an inequality, the first thing that we want to do is we want to make sure that it's written in the form y equals mx plus b. That's our slope-intercept form. The next thing that we want to do, identify your y-intercept, identify your slope. Then we want to look at the inequality. So check the symbol. I'm going to write inequality and determine if you're going to have a solid or a dashed line. And then look at the inequality again. Step number 4, look at the inequality and see if you're going to shade above or below. So exactly what you did yesterday. The only difference is today we're going to have 2 equations at once. So for this first equation, x plus y is greater than 2. I need to subtract x from both sides. Excuse me. So y is greater than negative x plus 2. That means that my y-intercept is at positive 2. My slope is negative 1. I'm going to write it as a fraction, negative 1 over 1. It's going to have a dashed line because the inequality is not containing the bar underneath, not equal to, and because it's greater than, I'm going to shade above. All right, let's look at these. So I'm going to graph that really fast. Beginning at positive 2, a slope of negative 1, down 1 over 1, down 1 over 1. I'm sorry, I have a scratchy throat. So now I'm going to make a dashed line. If you forget and make a solid line, you can always go through with your pencil eraser and just erase little chunks of your line. And remember, I'm shading above this. So I'm going to use that method that I talked about in case you don't have a highlighter. And I'm going to just shade it with a bunch of straight lines, making a bunch of horizontal lines on the above region, above my dashed boundary line. So that's my first inequality. My second inequality, negative 4x plus 2y is less than 8. I'm going to add 4x to both sides. So that gives me 2y. I need to move that. I'm going to write it down here. 2y is less than 4x plus 8. Divide by 2. So y is less than 2x plus 4. I don't have enough space on this. So y is less than 2x plus 4. That means that my y-intercept is positive 4 and my slope is 2. I still am going to have a dashed line. And the symbol is less than, so I'm going to shade below. So begin at positive 4. The slope of up to over 1, up to over 1, up to over 1. Dash line. And I'm going to shade below. So hopefully you see that the region for the solution area of the system is just the place that the 2 solutions overlap. So it's just this blue and red area. It does not include the line, okay? All right, let's do the next one. So for this one, I would have to subtract 3x from both sides. That would give me negative y is greater than or equal to 3x, a negative 3x plus 2. Because remember, I'm subtracting 3x. Well, remember that you cannot solve for a negative variable, so we have to divide everything by negative 1. That's one of our rules. When you divide by a negative, you have to flip your inequality. -3 divided by -1 is +3. 2 divided by -1 is -2. So I begin at -2. My slope is +3. Solid line. And I'm going to shade it's less than, so I'm going to shade below. So let's graph that one. So beginning at -2, I have a slope of 3. Slope of 3. I'm going to go in the opposite direction a little bit. And this is going to be a nice solid line. Again, I'm shading below. I'm going to use that same method. Just using lines, shading below my line. Kind of makes me dizzy as I draw a bunch of those little squigglies. Okay. Our second equation is already in slope-intercept form for us. Thank goodness. I begin at 5. My slope is 3. So begin at 1, 2, 3, 4, 5. My slope is 3. And this is a greater than symbol. So that means my line is going to be dashed. So I'm going to have a dashed line for this. And it's greater than, so it's going to be above. So when I shade above, what do you notice? What is the solution to this system? Where does my green and red shaded regions overlap? They don't. So this is an example of what no solution for an inequality system looks like. Your shaded regions do not overlap. All right, so yesterday we talked about lines like this. Remember, these are horizontal. And lines like this are vertical. So y is greater than or equal to -4 means I'm going to have a horizontal line going through the y-axis at -4. And because it's greater than or equal to, it is going to be a solid horizontal line. And because it's greater than or equal to, I'm shading above. So I'm shading above that line y equals -4, shading above it. So that means y is greater than or equal to -4. All right, now I'm going to look at the x equation. X is less than 8. So less than is going to give me a dashed line. And I'm going to shade to the left. 1, 2, 3. So this is 8 dashed line, putting a blue dashed line, and it's vertical. And I'm going to shade everything that is less than 8. So all values of x that are less than 8. So are you able to see your solution set? I'm going to kind of go over it with a highlighter. So your solution area is all of this, including that line, and then all of this space vertically, not including that line, but everything here. So it's a pretty large region. Remember, you can check this by picking a point that's not in your solution area, right? Like this point right here. That would be the ordered pair 10, -6. So remember, this is my x. This would say, if I let x equal 10, this says 10 is less than 8, and that's not true. That's why it's not in the solution area. And -6 is greater than or equal to -4, and that's also not true. You could also pick a point in the solution area, like the ordered pair 0, 0. And you could check that. 0 as my x value is less than 8. That is true. And 0 is greater than or equal to -4. That's my y coordinate, and that is also true. So remember how you know to check to see if you graphed it right, and you are able to pick a point in the solution regions. So this last system that we're going to graph has 3 equations, and this is the first time that you've seen a 3 equation system, whether we're talking about inequalities or equations. So the first thing I want to remind you is this is going to be a vertical line. This is a horizontal line. And then this one, I am just going to quickly put it in the form y is less than or equal to -x plus 4. So I solve for y very quickly, okay? So let's first graph our vertical line. X is greater than or equal to 2, so that's going to be a solid vertical line right here. And because it's greater than, I'm going to shade everything up to the right of that. And I'm actually going to use the highlighter this time because something really cool happens with this one. So this is everything that is greater than or equal to the number 2 on the x-axis. Our next one is y is greater than or equal to -3. So that's also a solid line, but it's going to be a horizontal line. And again, I'm going to shade above because it's greater than. So I'm shading everything that is above -3 on the y-axis. So every y value that is greater than or equal to -3. And then my last one is going to be a slanted line. Y is less than or equal to -x plus 4. So I begin at +4, and I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And it's going to be a solid line. Oops, that's not, I went crooked a little bit, sorry. Solid line like this. And because it's less than, I'm going to shade below it. So I'm using the pink color, but when I shade below, you'll see that the overlapping region is the region that is turning black. So something really cool about inequality systems is typically we ask questions about the shape that's been created. So we have just created a right triangle. The shape is a right triangle. And sometimes we may ask you something like, what is the area of the triangle? So if I were to ask you to calculate the area of this triangle, let's see, that means I need to know like my points. So this is 2, and this goes all the way to, let's see, this is our -3. This is down at -3. So if y is, I'm just trying to figure out where this point is. I think this is at, this is a horrible graph. I think this might be 2 to 6. Yeah, I think this is 6 units this way. So 6 units across the horizontal, and we're going to say 6 units across the, I don't really know, but the area of a triangle, remember, is the base times the height divided by 2. So 6 times 6 divided by 2 would be 18. So this triangle would have an area of 18. All right, so describe the shape. It's a triangle, name the vertices, find the area. So we have some word problems. I'm going to do these with you on Monday. We're going to do the word problems on Monday, but you have an interactive practice, 5 questions. Interactive practice, 5 questions in EDIA. Have a great weekend.